So let's see today's problem of the day of LEETCODE. So the question is target sum. Okay, so in the question you are given an array nums and an integer value target, and you want to build an expression. Okay, uh, out of nums, the given array, in which you can do the following thing. You can add symbols before the elements of nums, and which are those symbols? Plus and minus. Okay, before each integer you can of nums you can add these symbols. Okay, and then yes, at last you will get an expression. You can add any symbol, and you have to then find out like the number of different expressions that you can build which evaluates to target. Okay, so like for example, they have given an array nums to 1, so you can add plus before 2 and minus before 1, and then concatenate it to build an expression like this expression will evaluate to 2 minus 1, which is 1. So if target would have been 1, then yeah, we got one expression for that which evaluates to target. So now this is an example, like all there are all ones. Okay, and the target is 3, and yes, we have to tell the number of expression we can make such that like we add plus or minus before any integer. We can add, like we have two options, add plus or minus before any integer, and at last whichever expression is built, we have to evaluate that expression, and it should lead to 3, and we have to find the number of such expressions we can make. So what they have done is, like they have for uh, in the first answer, first type of expression which they have built is they have appended minus before the first one, and for all the ones they have appended plus symbol, so which is leading to 4 plus 4 minus 1 3. So we got one expression like that. Likewise, they have done for the second thing, like they have uh, appended 4 for all the other fours, or all the other ones, and the second one they have just appended minus for it, and for that, in that case also we are getting 3. So likewise, we are able to form 5 expressions out here, and in this second test case, only one element is there and the target is 1. We have only one, we have two options here, like we can append plus in front of 1, or we can append minus in front of 1. So if we append plus, so definitely we will get the target, and if we append minus, then we will not get target. That's why there is only one way to get the target. Yeah, so the intuition for the question is like, we are getting it like this is a DP problem. Why it's a DP problem? Because we are having two options for every element here. Okay, so like for the first element we have two options, can we append minus to it or can we append plus to it. For the second element also we have two options. For third elements also we have two options. So for all elements we have two options. So yes, we can apply recursion and then apply DP on it. Okay, and if we see the constraints, so the constraints are very less, length of nums is very less, and yeah, the sum in which the nums can go is like the maximum sum that can go is less than 1000, and target is from minus 1000 to plus 1000. Okay, yes, so yes, we can apply DP here. Okay, but the like uh, yeah, how will be applied? So what we'll take, we will take in some variable. Okay, in the recursion, and what we'll do for every element, either we can subtract that like element from some, or we can add that element from add that element in the sum. Why? Because if you are adding minus in front of that current element, then obviously you are subtracting it from the sum which you have got till now. And if you are adding plus, which was in this case, you are adding that element in the sum which you have got till now. Okay, so yes, you have only two options. You just add those element in sum, add that element in sum, or don't add that element in sum. Okay, yes, so actually let's try to do it. So first, yeah, first we have to, like we will make a DP array, or instead first let's try to do it in recursion. Okay, so let's suppose our recursion is something like a public int helper Okay, helper is our function. So we are taking three things here. I, which is the index, which is the we are working on, which current element. Then we have taken the nums array. Okay, nums array. And then we are taking the current sum which we have got till now. Okay, yes. So now if I is equal to nums dot length, so basically if all the expression you have made, okay, and now if the sum, this is equal to target. Okay, so let's define a target here in the public. Int tar is equal to it should be initialize here, this dot is equal to target. Okay, yes. So if the current sum will be equal to okay, target, so yes, we will return one, because this we got one expression, right? Because the expression is complete, we have taken all the elements, and yes, the current sum is reaching like is equal to target, so we will return one. But if it is not uh, equal to sum, and still it has completed the expression, then we will just return zero, because we doesn't got the thing. Okay, they are not equal, that's why the expression will not evaluate to target. Okay, now every time what we'll do, so every time we have a thing answer is equal to zero. Okay, is the number of ways you can do it, do append like the current element. Okay, now you will just call, okay, answer plus you will make a call. You have two options. First option is add element in nums, not nums, sorry, in sum. Add nums of I, nums of I in sum. Okay, so yes, just go for the next element, put nums as it is, and increase sum to nums of I by nums of I. First, this is the case. Second, the case is add, no, not add, subtract element nums of I in sum, from sum. Okay, so that would be case of yeah, we are going to next element, we are passing nums array, and we are just subtracting it from sum. Okay, so these are the two cases, and at last we will return the answer. Is the number of ways we are getting from by doing both the things. Okay, like either subtract it or either add it, and yes, at last we will return. And now if we call it helper nums, and yes, first we have to pass zero index, because we are starting from zero, and yes, target will be at zero at starting. Yes, and if we return this, we should get our answer. Let's try to run this. This is pure recursion, we haven't applied dp till now. Okay, so it's working. Let's try to submit it. Let's see if it works for like bigger test cases. Okay, it's still working. Okay, because like the length of the nums array is very small. It is very small. Okay, is only 20. But you know what, uh, if it would be like more than, like I guess 500 or 100 also, I guess it would give TLE to us. Okay, because what we are doing, this is the time complexity for this is like 2 to the power n, because for every n is like length of the array, so for every element we have two options, and that's why it will go to 2 to the power n. So, and we are this is the problem, like which are having overlapping sub problems. Okay, and you are calculating again and again same thing. Okay, so we can optimize it using dp. So what we'll do, we will just take an dp array, 2d array. Why 2d array? Because we have you can see we have two variables here which are varying in a recursion call, that is I and sum, the element and the previous sum which you have got till now. Yes, so what we'll do, we will initialize dp with a 2d array. Okay, int how much it is, yeah, nums dot length. And because they have said that what they have said, yes, the sum is less than 1000 always, so uh, we can take here 1001. But the problem is that the target can be negative also. Okay, so, and you can't obviously have negative indices in the array. So what I will do for that is I will just take 2001. Why I'm taking 2001? So like for the first from 0 to 1000 will be for negatives, okay, and from 1000 to 2000 will be for the positives, okay. So whenever I am trying to index the dp, I will just index it by adding 1000 in it, okay. I hope you got that. Yes, now let's apply dp here, okay. First let's initialize, okay, the dp, okay. Let's initialize the dp with -1, okay. In java it's hard to do, yeah. X minus 1. So we have initialized the dp array, 2d dp array. Now yes, if dp of I comma sum plus 1000, okay, sum plus 1000, this is equal to -1, then we will do this thing for us, okay. If that is not -1, which means that we have already calculated that for us, so we will just don't calculate it again. we will we will not calculate it again, and we will just return it, okay. So yes, at if it is not -1, we will just return it, okay. Yes, this should work. Let's try it this. Yes, it's working. Let's try to submit it. Yes, it's working, and it is having obviously the better complexity, like it would be having n square. Yeah, it is showing here 2 to the power n. I don't know why, but yeah. uh, uh, if you see, like the n is like 20, and the yes, the n is 20, and this thing, the sum can be from like go till 1000, so it will be from n into some complexity, I guess. uh, yes, okay. Thank you all for watching.